Hey guys, today I wanted to take the opportunity to go over Boolean expressions and conditional statements. We're actually going to spend 2 days on this. So today, this video is going to go over most of the concepts and just talk about the syntax and theory behind these Boolean expressions and conditional statements. And then tomorrow we're going to look at some more applications in terms of what type of problems we're going to see on the AP exam and go through specific problems. There's only one assignment for this one. It's already posted on Google Classroom. It's a multiple choice practice exam, and it's also on the College Board website. So all you need to do there is just go sign into myap.collegeboard.org, and then the nice thing about completing it on there is that it will give you the answers after you complete it, tell you what you got right and what you got wrong with explanations. So I would say the good thing for you to do is to complete it on there so that you get that instant feedback, and then if you have follow-up questions you can come on Thursday at 9:30 in the morning to my office hours, and I'll answer any questions that you have on that assignment. That assignment's open all the way until April 20th. It's going to stay on Google Classroom the rest of the year, so you'll have it for review all the way up until the AP exam. But I would definitely suggest you work through it as we're going through it, just because I think the pacing is meant to help you out, and if you keep procrastinating and pushing it off until the end of the school closure or into spring break or even beyond that, then it's going to be difficult to try to cram all that in at the last minute. So the first thing we're going to go over is some Boolean expressions. As a reminder, we're going way back to basically first month of school, just going through and talking about what all of these things mean and talking about the Java syntax and how we use them in programs, and then tomorrow we'll look at some applications. So the first one that we're going to look at are relational operators. So these ones are very similar to what we've already seen in math class. So a lot of them you will understand and just be able to see right away what we're doing. The important thing that is kind of unique to computer science is that all of these relational operators are comparing numerical values, but they're telling us either it's true or it's false. Right? In math class, it was always something like an equation, and we were trying to solve it. These ones instead are comparing actual values, and they're just telling us whether it's a true statement or a false statement. These are very useful in conjunction with like if or conditional statements. So that's why we're going over these at the same time. So similar to math class, we have the greater than and the less than. The greater than or equal to and less than or equal to look a little bit different than what we've seen in math class, because we don't have a keyboard button for the less than or equal to symbol. So we have to use two different keyboard strokes to combine them to create those. So we have greater than and then equal sign after it, less than and then equal sign after it. To compare two numerical values to test if they're equal to each other, we use equals equals. This is contrasted with the assignment operator, which we saw in our variable review already. So the equals equals is different than a single equal sign. The equals equals is always going to return true or false. And then there's not equal to, again returning true or false. If the values are not equal to each other, it returns true. If the values are equal to each other, it returns false. So it's just the opposite of the equal to relational operator. We also have Boolean operators. So these operators are actually what compares or combines different Boolean variables or values together, like a true or a false value. And so the and the or operators actually combine two different values, whereas the not works on one value. Unless, when we see later, you can apply the not to compound conditionals, and we're going to see that in the next slide. So the not just flips the Boolean value. So whether it's a variable or just a value, it'll change a true value to be false, and it'll change a false value to be true. The and combines two different Boolean values or variables, and it'll only return true if both of those individual values are true as well, and it returns false otherwise. So you can see the one unique case here, which is true and true will return true. All other combinations, true and false, false and true, false and false, will all return false. For the OR operator, it again combines two different Boolean values or variables, and it returns true if any one of the expressions is true and false otherwise. So the only unique combination here is false or false returns false. All other combinations, true or true, true or false, false or true, all returns true. So the only unique one is false or false. So you can see that the unique cases are kind of opposite of each other. The true and true returns true, whereas the false or false returns false. In Java, programmers, just in general, not even applying to Java, are just obsessed with efficiency and runtime efficiency. And so programmed into Java is this idea of short-circuit evaluation, which basically says if I know the first statement and I can determine the outcome based on the truth value of that first either variable or value, then there's no reason to even look at the second one. So the important thing about short-circuit evaluation is the second part of the Boolean, the compound conditional, the second part of the Boolean operator is just completely ignored. It's not even read, so even the compiler won't even read it. So if there are things like syntax errors or compiler errors, it actually can skip over syntax errors. So the AND case, it says if the first statement is false, it's guaranteed that the combined truth value is also false. So we see our two different cases here. We have false and true is false, false and false is false. And let's look at why that is. So if we look at the AND, it's only true if both expressions are true. So as soon as the first expression is false, it doesn't matter what the second expression is. It's going to be false no matter what. So the short-circuit evaluation says if the first condition is false, I don't even read, or sorry, I keep saying condition. If the first statement or the first variable or the first Boolean value is false in an AND compound conditional, then I don't even read the second statement or variable or value. I just skip over it because I automatically know that it's going to be false. For an OR case, we have just the opposite. If the first statement is true, it's guaranteed that the combined truth value is also true. And if we look back at the reasoning for that, right, it's true if any one expression is true. So if the first Boolean value is true, it doesn't matter what the second Boolean value is, the combined truth value is going to be true. So again, we skip over this second statement. Okay. Again, tomorrow we're going to be looking at applications of these to see different types of problems that use short-circuit evaluation and things like that. The last thing dealing with Booleans is De Morgan's law. De Morgan's law is actually a logic principle. It's used in math classes, it's used in logic classes, and it also obviously applies to computer science classes. And basically the application to our computer science class is if I have a not operator in front of a compound conditional, I can essentially distribute it. There's no distributive property in this idea of computer science, but we can think of it as similar to our distributive property from math class, which says if there's a not outside of the parentheses, then I can apply the not to everything inside of the parentheses. So in this case, I end up with a not A, the AND turns into an OR, and then I have a not B. So these two expressions are logically equivalent. Okay, it basically means they're equal to each other, logically. And then here, if I have an OR in the middle, same thing, it applies a not to the A, the OR, and the B, so it becomes not A and not B. Now, just to talk a little bit about applications, because this is very theoretical, is that we're going to see problems where they're going to ask us, you know, an example Boolean expression with a lot of compound conditionals and nots in there, and they're going to ask you, this is equivalent to what? And they'll give you a list of maybe 5 multiple choices, and then you have to see which one the example is equivalent to out of those multiple choices. And so we have to know how to quickly apply De Morgan's law to simplify expressions. The important thing to understand as well is that this works in the reverse direction. So if I have a not in front of both, I can basically factor out the not. Like in a math class, you can factor out the not and move it to the front. So I can go from this type of expression on the right to the one on the left as well. Moving on to if statements. If statements are really important in programming. It shows a lot in both the multiple choice and free response portion of the exam. In the multiple choice section, we don't see a lot of problems with just if statements. A lot of times they're combined with other concepts. So some concepts that they may be combined with are array algorithms, for loops and while loops, recursion. So we'll see it in combination with a lot of other problems, but for now we're going to look at just the if statement by itself without any of those other concepts, because we haven't gone over those in review yet. So the if statement allows for decision making and branching in a program, and essentially it makes it so that if this condition, which is inside of these parentheses, if the condition is true, then these instructions in what we'll call the body of the conditional will be performed. But if the condition is false, it effectively skips over the body, so these statements that are inside, in between these curly brackets, are not performed. So it skips over it. So it all relies on this condition. So if this condition is true, these instructions are performed. If the condition is false, it skips over it. What we see a lot more often are these if-else statements, which allow for a different set of instructions to be executed if the condition is false. So if this condition is true, again, similar to the previous slide, all these instructions are performed, and it could be as many statements as I want in here. But if this condition is false, it again skips over the body of the conditional, the body of this if block, and then it goes to this else. And whatever the instructions are in this else block, those are performed when the condition is false. So it effectively makes it so that I can have my normal program is running through, and then there's a branch. If the condition is true, I follow this path. If the condition is false, I follow a separate path. And then after whichever path I take is executed, it returns back to my normal program. There's a few things syntactically about the if-else statement that they will use in the AP exam to create some kind of tricky situations. And one of those that we want to pay particular close attention to is the dangling else. And before we get to that, what we have to understand is syntactically, if we look at the previous slide, we have these curly brackets here to denote the beginning and end of the if block, and then the beginning and the end of the else block within this conditional statement. But those are actually not necessary if I only want to execute one line of code following the condition. So if I mentioned here I can include as many statements as I want in this body, but if I only want to have one statement, what I can do is I can just put if this condition is true and then put one statement here, and I don't need those curly brackets. And then I can also do that with an else. So when the condition is false, I just execute again this one statement here. So this only works if there's one line of code following the condition. But this causes a problem when using nested if statements. So if I look at the white space here and the way things line up, it appears that this else down here is connected to my first if. But the rule is if I'm not using curly brackets, the else will always be tied to the closest if statement. So in this case, this else is actually connected to the second condition. So the first condition, right, if the first condition is true, then it'll perform these instructions, right? And then it'll check the second condition. If the second condition is true, it'll perform these instructions. Now this else is only accessed if the first condition is true and the second condition is false. And actually there is no else tied to this first condition, even though it appears that there is. So this is important. They'll make problems look like the else connects to the first if, when in reality, remember in Java, the white space is not read by the compiler. The white space doesn't affect the program at all. So whenever we don't have these curly brackets, an else block will always be associated with the closest if block. So it doesn't matter what the white space looks like. So you'll see problems like this that will be intentionally misleading. Okay? That's actually the last thing that I needed to go over, or that I wanted to go over today. Tomorrow is Wednesday. I will post another video with more application style problems, looking at the different types of if statements and the different types of problems that we'll see. on the multiple choice portion of the AP exam, but I would recommend you get started on the assignment. It's called I think it's called If Boolean Review Homework. It's on both Google Classroom and the College Board website, and if you have problems with some, you can always skip them and come back to them later. And then I would not submit it today. I would actually just save your progress today, and then after the video tomorrow, go back through the problems again, see if there's anything that you want to change, and then submit after the video tomorrow. Then you'll get feedback based on that. You'll see the different problems that you had issues with, and then on Thursday during office hours, you can come up and you can ask questions, you can ask me to go over problems, and we'll go over those together. Alright guys, have a great day.